Okay, so today I'm going to be going through, working through this problem on LeetCode, which is the integer to Roman. So I haven't come up with the solution yet, so I thought it'd be a good opportunity to go through the problem-solving process and how a developer or someone that's trying to solve this problem might approach it. So let's just go through what the problem actually is. So you've got Roman numerals are represented by 7 different symbols. So for those of you that aren't, well, you probably are familiar with Roman numerals, but if you're not, in Roman times they used to use these letters to represent numbers. So each letter has a value, and there are rules around how the letters can be used in combination with each other to produce numbers. So for example, 2 is written as II. So yeah, you can see in this table, I is equal to a 1. So 12, for example, is 10 and 2 i's. So that would be the number 12. So the number 27 is created like this. So you've got 2 x's for the 10, so that's 10 and 20, and you've got a v, which is 5, and 2 1's. So you add all that up and you get 27, which is shown there. So yeah, so it looks like Roman numerals are usually written from the largest to the smallest, and yeah, there are some strange rules where I guess to reduce the length of the number in Roman numerals, you don't want long things like I. Instead, it's written as IV. So that is deducted from the V, which is 5. So these are some simple rules, and I think the solution to this is probably reasonably simple. To be honest, I would probably put it as an easy, because I think it's easier than a lot of the other the ones that are in the easy category. But maybe I'm missing something, so we'll work through the problem and see how it goes. So I guess reading this, the first thing I notice is that we have 3 rules here that seem to be very, very similar to each other. So this may be an opportunity to reuse an idea. So that's something I'm vaguely aware of. The other thing that I'm noticing is I'm just kind of thinking about the general structure of these Roman numerals. And I'm noticing that each digit, I think, can be represented by a set of numerals. Yeah, I think that's right. So if I open something like Notepad, and let's just say we have the number, I don't know, 347. So in Roman numerals, that would be CCC for the 300, the 40, so 40 would be, well, you'd think it would be XXXX, but because we know there's a different way of doing that, it would actually be XL from the look of it. So yeah, X can be placed before L to make 40. And the 7 would be VII. So I think looking at just the general structure of Roman numerals, you can see that the digits appear to be independently assignable. So when constructing the Roman numeral, it seems like we can treat each character or each digit in the number as an independent operation. So let's see if we can do that. I suppose the thing we have to think about is how would we map. So say here we have a 4, but 4 on its own would be VI. Sorry, IV. But because it happens to occupy the tens column, it's not IV, it's instead XL. So I think a good starting point would be to create some kind of generic function that constructs a digit where you can provide the characters to use to represent the different things. So I'll show you what I mean. So I'm going to create a function, digit to numeral. Let's call it that. And we'll pass in a digit, which will be a number. And let's just think. So I guess we can just be really dumb here and just go, yeah, let's just be really, really simple. If the digit is equal to 1, I mean, this is really, really simple. Let's just see if there's an easier way of doing it. Yeah, I think it's going to be a bit long, but I think, no, I'll tell you what, let's look for repeating characters. There's going to be a way to repeat string. Yeah, it might even just be repeat. Yeah, it's repeat. Look. So I don't think so. You might object to me Googling things and say, "Oh, you must know all these things," but it's, you know, a good developer doesn't necessarily have to remember everything. You just have to remember that certain concepts exist. There you go. So this is doing exactly what we want. So what we can do then is in our function, we can say if it's less than or equal to 3, what we'll do is we'll take the character. Now this was the thing I was gonna do. So we'll go ones character as a string. Well, let's just go 1 character 5 character as a string, and 10 character as a string. Yeah, that looks pretty good. Good. Okay. So if it's less than that, so we're going to take the 1 character, which will be I suppose. So we can go 1 character dot repeat, and repeat the number of by the number of digits. So if it's 2, oh sorry, what have I done here? So if it's 2 here, you'd get 2 occurrences of this 1 character. So just to give an example of how I'm expecting to call this. So I don't know, I'm just going to put in the number 2, and we would pass in, let's say, I, b and x. Yeah. The good thing with this is then we can just modify the things, the rules, based on the position that we are in the number. So we could say x, L, and C, and M, D, and C. So if we take the example here, the way that we would construct this number would be with 3, 4, and 7. And then we just have to concatenate the results of these values. And after we've implemented this function fully, that should work. We'll need a better way to do this in a moment. So let's complete this. So if the digit equals 4, then we're going to want to return, that, by the way, return, it would be the 5 character, but it would be the 1 character before it. So we should be able to do that. I'm in the habit generally of using these backticks. It generally is a nicer, more readable way of writing code. A stylistic choice, of course. So if the character equals 5, then we just return 5 character. We'll have a few more cases here. So if it equals, so if it's none of these, and yeah, then it can be less than 8, I guess, because it would be VIII. That would be 8. So I'm basically trying to reproduce this one here, but prefixing with the V. So if we're less than or equal to 8, then we can have 5 character followed by a number of these. We would repeat, and we can deduct 5, so that if we're, so we know we're between 6, 7, or 8. So if we're 6, 6 minus 5 is 1, so we only have 1 of the 1 character, so 1 I following the V. If it's 7, 7 minus 5 is 2, and if it's 8, 8 minus 5 is 3. So that will give us V and then a number of I characters following it. And then we have some special cases for if we're 9, which would be a 1 character followed by the 10 character. Great. Now, one thing I haven't considered is how 0 interacts here. That may end up being a complication, but I'm not so sure, actually. It might be something we can completely ignore. For instance, if we had 1001, I've got a feeling that's just MX. Sorry, MI. So the zeros, I think we can ignore completely, which is quite convenient if that's true. So that's fantastic. We have this function now that we can use. Don't know what's going on with the syntax highlighting here. It's a bit strange, but we'll go with that. And yeah, so I think this is a good approach. What we need to do now is we need to handle the various possibilities for the range of numbers. So we've got 1 to 3999. So we may not have all of these digits, is essentially my point. An easy way of doing this is to just convert it, just to treat it as a string. It's not the most efficient way, but it's probably the simplest way to just quickly do a solution. Having said that, it's a bit of a faff converting each character to a number again each time, but there is another way. So what we could do, if you've seen any of my previous videos, I explained about the log function, log10. So if you have a number and take log10 of that number, so math.log10 of number, this will give you the, so if you take 10 to the power of a number, say 10 to the power of 2, 10 squared, taking the logarithm, like the log10, logarithm to the base 10, will do the inverse of that calculation. So it asks the question, in base 10, to what power would I have to raise this number in order to get this result? So it's a good way of getting the length of a number. So if you think of 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3 equals 1, 10, 100, 1,000. So when we do 1,000, log to the base 10 of 1,000, this will produce the value 3. And if we have 100 as our input to the log10 function, we will get 2. So one way of thinking about it is it gives you the number of zeros on the end of the number. So that will give us the length of the number quite nicely. So let's do that. We can go zeros, I suppose. And we need this because we need to loop over the numbers, essentially, don't we? We need to loop over the digits. So we need to know how many digits we have to loop over. So let's do that. I'm just wondering whether it's easier to just treat it as a string. Let's just do it as a string. It's so much easier to explain. So yeah, let's do that then. So number as string. It might be worthwhile to just play around with that other idea to try efficiency improvements later. So dot to string, and then we can just go for var I equals number as string dot length -1, and we want to keep iterating until I is, while I is greater than or equal to 0. Oops. And I minus minus. So that's good. So we can get the individual character, and I guess, yeah, in fact, let's do this slightly differently. We'll do not while it's less than that, and do I plus plus, and yeah, we'll pass that in. So one other thing we need to do is we need to handle each position in the number, so each digit differently, because each digit requires a different set of numerals. So if I equals 0, then we're going to do one thing, otherwise we'll do something else. And yeah, we've potentially got up to 4 digits, so I think that's fine. So now we're going to pass our digit in, which is going to be number as string, and we're going to get the relevant digit. So we could actually go from left to right. I was going to go from right to left, so from the units to the tens to the hundreds to the thousands. But actually, there's no reason to do that. I think we can just go from left to right here because it's more convenient with our iterator. So we can just go I. We'll convert it to a number. I'm pretty sure you can just go number like that. And we want to specify if we're in the no, we can't do that actually, because yeah, we need to start from the right because we don't know how many digits we have, so we have to start from the right. So if I take this example, we have to start on the right hand side because we can't start here, because we're gonna, if we did, we would be assuming that's the thousands, which it isn't. So we need to start on the right hand side, which means we need to take the length. Well, let's just create a new variable. Digit pos equals number as length minus 1, which would be the final position, minus I, so that we iterate backwards from that edge. And yeah, we can use this here. And in the rightmost column, we can use I, V, and X. And we'll modify these accordingly. So we'll use X L and C, L and C, and we can use here C, D, and M, and the only one that really matters here is M. For argument's sake, we'll just put a hash in these, but they shouldn't ever be used because specified in the question is that we only go up to 3 in this character, so we shouldn't need these other ones. Now, I think this will work. I suppose the only final thing to do is to append the digits. So we can go result equals, well, an empty string, I guess. And we can just append this should work, I think. Return results. So I reckon we should run that, see how it fares. Okay. Okay, I think just haven't got colons on the end. I think. Oh, that would help if I put else if in there, wouldn't it? Okay. This is where having a nice development environment is really helpful. Can't rely on my memory with all this stuff. So that seems to have passed, so that's quite cool. So we'll submit that and see if it passes all of the other tests that it throws at it. Okay, so we've got a wrong answer, which is perfectly good, but you know, I like that. We can still give us an opportunity to debug the problem. Okay, so we've got VIII. So, okay, so we've got completely... I see the problem. I'm appending to the wrong side here. So what I've observed is we've actually got the correct components here. We've got VIII and L, but they've just been appended the wrong way around. So we can easily fix that. Plus result. And here and here. There we go. So hopefully that little bug fix will produce... Okay, so that appears to be a valid solution. And the runtime is reasonably fast, faster than most. So I'm okay with that, I think. We're using a string here, which, you know, we could make that more efficient by using the math.log10 method. But fundamentally, I think this is a reasonable solution, and I'm going to call it a day there. So thank you, everyone. I'm Will. I'm the Random Coder. And yeah, thanks for watching. Please subscribe.